Hi, my name is Xinrong. I'm a senior at NYU University, major in mathematics and computer science. I'm planning the Master of Science in Mathematics and Finance at NYU Korean because I want to build a career in quantitative finance. I found that fascinating to study market data, test the ideas, and see how mathematical model could explain stock movements. Later, during my internships, I realized that I truly enjoy solving the financial problems with code and data. That sense of curiosity and problem solving motivates me to learn more and divide my career in this direction. This summer, I worked as a quantitative research intern at Acres Fund in New York. My main project was to design and backtest the delta-neutral option strategy. I had played well and had the right background in math and programming, but when I started combining theory with the real market data, I still faced three major challenges. The first challenge I faced is how to get the data right. Option data always looks clean until you actually work with it. There were missing strikes, delayed codes, and inconsistent time steps that made the results unreliable. I realized that if the data isn't right, the model doesn't mean anything. So I took time to summarize all the problems I found and built a small Python pipeline to clean and align the data. I added the filters for liquidity and checked the outliers by tickers and expiration. Once the data was consistent, the strategy's results became much more stable. I learned that good models start with good data. In quantitative finance, I know we need to spend the real time understanding data lineage, cleaning, and validation. The solid preparation at this stage is always the foundation of later success. The next challenge was to keep the model stable. My first version performed beautifully in sample but fell apart out of the sample. That was frustrating. It made me realize I was outfitting and trusting patterns that were not real. I went back, simplified my features to focus on momentum and volatility screws and used the rolling windows for testing. I also logged every round to see when signal started to drift. The performance became more realistic and repeatable. I learned to stay skeptical of perfect results and to prefer models simple and robust. That mindset is essential in quantitative finance, where reliability matters more than short-term success. The last challenge was about the execution at risk. On paper, my portfolio looks delta neutral, but in the realm of trading, cost slippage and liquidity gaps can erase profits. I added position limits, portfolio level data checks, and simple execution rules to avoid the same markets. The returns dropped slightly, but the drawdown became smaller and easier to explain. That trade-off taught me that a strategy isn't just a formula, it's a complex system that must survive the real market conditions. This experience showed me that what quantitative finance really is: a mixed theory, coding, and constant problem solving. It taught me that to think in full cycle from clean data to stable modeling and realistic risk control. It also taught me to communicate results clearly because every number tells a story about assumption of limits. These lessons are exactly why I want to pursue the MS in Mathematics in Finance. I want to deepen my understanding of stochastic modeling, machine learning, and risk management, and apply those skills to build strategies that works in the real world. Walking through those challenges give me both confidence and humanity. Confidence that I can connect math and markets, and humanity is to know that details always matters. That balance is what I want to keep developing in my career in quantitative finance. So thank you for watching and for considering my application.